let's go ahead and use the power rule to take the antiderivative of 1 over x. Now, just like a quick reminder, I mean, if you have something like 1 over x squared, we rewrite it as x to the negative second. We take the antiderivative by adding 1 and then multiplying by the reciprocal, making sure we have a plus c. All right, do that with 1 over x. What happens? I'd rewrite this as like x to the negative first. And then I get like x to the 0 if I add 1. And then like multiply by the reciprocal of 0. Is that like that? Turns out the power rule does not work for x to the negative first. Because that's not correct. Okay? But there is an antiderivative of 1 over x. Because we remember the derivative of log x was 1 over x. You remember that? I hope so. Therefore, the antiderivative of 1 over x must be log x plus c. Kind of. It is, but it isn't. Remember the log function, the reciprocal of e to the x, you only plugged in positive values. That means its antiderivative, 1 over x, we'd only be using positive values for 1 over x. But if I went the other way around, if I started with 1 over x, well, 1 over x exists for every value of x except for 0. I could plug in positive or negatives. Which means we need log x to exist for positive and negative values. To let that happen, we're going to use an absolute value. So no longer kinda, definitely. This will allow us to plug in any value except for 0 into that function, and we will get a value out of it, which will be important in the future. But for right now, not that important, actually. Okay. So power rule doesn't work for x to the negative first. The power rule works for every other power, any power in the denominator. As long as it's not 1 in the denominator, we're still going to use the power rule. Okay, so don't let this confuse you in the future. If you see 1 over x squared, the antiderivative is not log x squared. The antiderivative will still be using the power rule, negative 1x to the negative first. Okay, so if you need to make sure we are comfortable with that, write up 1 over x squared in the top right. So you remember, use the power rule for every other power. All right, now, e to the x, its antiderivative. Well, if you remember the derivative of e to the x, you'll be able to easily find the antiderivative of e to the x. It's just itself. The derivative of e to the x is e to the x. The derivative of e to the x plus c is e to the x. Okay? So we're good. We have 2 differential equations we can solve. Let's go ahead and solve them. Don't take up too much space. I'm actually going to fill in some stuff in between your top part and the bottom part of your notes. So e to the 0, make sure we know that that's 3. C is 2. So we get f of x e to the x plus 2. Here, f of x would be log absolute x plus c. F of e would be log absolute e plus c equals 2. Now I got rid of the absolute value, and this is important. Once you take the absolute value of your value, and you have a positive, the absolute value goes away. So I'm plugging in e. I don't need to write the log of absolute value of e, because the absolute value of e is just e. So now I just have log e. Doesn't really make that big of a difference, just so you know where the absolute value went. We need to know what the log of e is. We need to know what the log of 1 is. We need to know what the log of e to any power is. If you need a reminder, the log of e to any power is the power. Not too long ago, we had derivatives of logs and analysis of log functions, maxes and mins, points of inflection. So recall log of e would just be 1 because it's e to the first. The log of 1 is 0 because that's e to the 0. You have to know those. That's important. So this is 1 plus c is equal to 2. C is equal to 1. Here's my solution to my differential equation. Okay? All right, good start. Now, the last antiderivative rule we are going to learn is a rule that will undo the chain rule. Now, somewhere, wherever you have space, whether it's on this page or the previous page, let's recall the chain rule. So I'd like you to take the derivatives of the following functions. Sine of 5x e to the 3x log 4x minus 2. Let's just start with those. Okay, I'm taking derivatives here, not antiderivatives. Now, if you don't remember, this is a chain rule. You need O's and I's. I got O is sine, the I is 5x. I take the derivative of O and I and multiply them together. So I'll get cosine 5x times 5. We have this extra 5, right? So the derivative of the inside. Okay, do e to the 3x and then log of 4x minus 2. Okay, the derivative of e to the 3x will have a 3 involved. Log of 4x minus 2 would be 1 over 4x minus 2 times 4. The 4 shows up. If I did something as simple as like the derivative of 4 minus 3x to the 4th power, we would take the derivative of the outside, and then we'd have to multiply by that negative 3. I want you to understand why you have to have this number when you're taking the derivatives. It's because of the chain rule. Everybody see how, like, I need this negative 3 because I need the derivative of the inside. I need this 4 because of the derivative of the inside. I need this 3 because of the derivative of the inside. Cool? Is that all clear? Okay. Because we're going backwards. We already understand this one, but this will help me kind of hopefully explain the antiderivatives of that guy, and that guy. Okay? The first thing that is important is this power of the 5. x to the fifth. We need an x to the fifth because the derivative is going to be an x to the fourth. But then we know we are going to have a 5 when we take the derivative of x to the fifth. To counter that, we need a 1/5. Okay? Now, if it's cosine of 5x, our first instinct is the sine of 5x. Please discuss with your neighbors if that is correct or not. And if it's not correct, what is the correct antiderivative of cos 5x? Because the derivative of sine of 5x is cosine 5x times 5, this is not correct. Because if I took this derivative, and we can always check our antiderivatives by just taking the derivative of what we think our antiderivative is. If I took this derivative, I would not get cosine 5x. I realize this 5 I need to take care of, just like I would need to take care of the derivative of x to the fifth, that 5, by having a 1/5. So this is showing me, understanding the chain rule, that I need a 1/5 in front of that sine 5x. And I hope we all kind of figured that out. Now, I don't want to stick with 5. I thought that it was a good idea to stick with 5, but I don't want it to be confusing. Let's change this to e to the 3x plus 2. Go ahead and throw in a plus 2 in there. Oh my goodness. I end up doing the same thing as the next one. Change it. 6x plus 5. 6x plus 7. All right, good. Just can't have the same numbers over and over again. Our initial instincts are that, okay, well, like e and its derivative is always like the same thing. So I think it's e to the 6x plus 7. But since I know the chain rule, I know this is not the correct antiderivative, because if I took this derivative, I got an outside and an inside, it'd be the derivative of the outside times the derivative of the inside. I would have a 6. So fix your antiderivative. The antiderivative is not e to the 6x plus 7. That's it. You would just need this reciprocal of the coefficient of x. Now this one is tricky. Some of us might think to cube things, but you can't just cube 3x and you can't just cube 2. You'd have to distribute a lot of stuff. But instead, we can think about maybe just working on the outside. And what we've been doing is kind of working on the outside first. And I thought if this is x to the fourth, I would maybe have some x cubed. I'd maybe have some x to the fourth times 1/4. And I think maybe that's correct. Maybe it's 1/4, 3x plus 2 to the fourth plus c. But then I think about the derivative of 1/4, 3x plus 2 to the fourth. And I'll get the correct beginning. I'll have 3x plus 2 cubed. The 4 comes down, multiplies by this 1/4. But then I need to take care of that 3 because I have to take the derivative of the inside. Which means I need a 1/4 because of my power, but I also need a 1/3 because of my inside. And all of a sudden, I get 1/12 3x plus 2 to the 4th plus c. These are the trickiest ones because there's two kind of reciprocals that you need to worry about. Okay? This is our kind of second to last antiderivative rule that we have to worry about. The last one we'll worry about in the future. That is, if I have some composition where I have ax plus b inside of some function and I want to take the antiderivative of it, I will just take the antiderivative of the outside. I'll leave the inside alone, but I just need to remember, because of the chain rule, if I took this derivative, I would have a after it. I need to make sure I multiply by the reciprocal of the coefficient of x. So, in words, take the antiderivative of the outside, multiply by the reciprocal of the coefficient of x. Okay, I'm going to throw in a third example in between these two. We got antiderivative of 1 over 3x minus 2. I want you to do the antiderivative of 1 over 3x minus 2 cubed and the antiderivative of e to the negative 2x plus 3. Okay, start with the one all the way to the right. The one on the right is probably going to be the easiest. The other two, confusing to some. I know that this is kind of in the form of e to a power, where in the power I have ax plus b. And that's kind of what I'm thinking. This is like e to a power. And I got an ax plus b in the middle. The antiderivative of e to the power will be e to the power plus a c. But since I have a coefficient of x, and since I know the chain rule, I know that if I took the derivative of this, I'd have a negative 2. I don't want a negative 2. I just want e to the negative 2x plus 3, which is why I need a negative 1/2. Okay, got that one? Let's look at this one. I know this is just similar to an ax plus b to the negative 3rd power. That would be like the outside. I can take the antiderivative of the outside, leave the inside alone, but then make sure I multiply by the reciprocal of the coefficient of x. Now, make sure we add 1 to negative 3 to get negative 2. Make sure you're using the power rule like you normally would. So I'd add 1 to get negative 2. I'd need to multiply by negative 1/2. So I get this to the negative 2nd times negative 1/2. Take the antiderivative of the outside. Inside gets left alone, but don't forget to multiply by the reciprocal of the coefficient of x. And I get 1/3 times negative 1/2 times 3x minus 2 to the negative 2nd plus ac. So this is negative 1/6, or negative 1 over 6, 3x minus 2 squared plus c. Okay? See if you can do the one all the way to the left. a hint. Think of this as something to the first power, as like the outside. We know that the power rule does not work for x to the negative first. The power rule does not work for stuff to the negative first. Think about it in terms of 1 over x. If you know the antiderivative of 1 over x, you know the antiderivative of stuff to the negative first. It's tricky. The natural log function would be the antiderivative of the outside. Leave the inside alone, but make sure we remember to multiply by the reciprocal of the coefficient of that x value because of the chain rule. Okay? Tricky. In the bottom right corner, you're going to add this to your notes. Using the same thought process, we are going to be asked to take the antiderivative of a number to a power. We're going to use 2 to the x as an example. So throw this in the bottom right corner. Does anybody remember what the derivative, the tangent slope generator for 2 to the x is? Anybody want to take a stab? I'm not surprised you don't remember it, because we don't use it often. Anybody? Two to the x, natural log 2. Anybody remember that? Nope. Okay. Using the same kind of thought process, knowing that the derivative of 2 to the x is 2 to the x log 2, what's the antiderivative of 2 to the x? I need a function whose derivative is just 2 to the x. Nice. Here, I'll start you all off. It involves 2 to the x. But that's not the right answer, because the derivative of 2 to the x is 2 to the x log 2. So like, this is close to having a derivative of 2 to the x. But the problem is, if I take the derivative of 2 to the x, I get 2 to the x log 2. I need some way to get rid of the log 2. Can you do it? Mr. Dunlap, what do we get?
To the x, 1 over log 2.
That's it. We need the reciprocal of this thing that pops up. It's almost like it's a chain. And what we've been doing is we've been multiplying by the reciprocal so that we can undo that chain. This 1 over log 2 will cancel with that log 2, and I'll just have 2 to the x. Tricky. All right. Let's solve some differential equations, starting with e to the 3x. With f of 0 equal to 3. Very good. Very good. We're not forgetting, because of our knowledge of the chain rule, that the antiderivative of e to the 3x is 1/3 e to the 3x plus a c. You have to have that 1/3 because you know the derivative of e to the 3x using the chain rule would be e to the 3x times 3. The 3 and the 1/3 cancel. F of 0 is 3. F of 0 equals 1/3 e to the 0 plus c, which is 3. C is 9/3 minus 1/3, which is 8/3. Okay, you guys do the next one, same deal. Thank you. Oh, it's different. This is a second order. This is F double prime. So we got to go to F prime, and then we got to go to F. I need a 1/2. I get my first C is 5/2. I take that antiderivative, and I realize I need another 1/2 to be multiplied by the existing 1/2. I need a 1/4 now. I'll need a 5/2 x and then a second c. A little bit of a fraction work, a little bit of arithmetic. Never hurt nobody. Okay, we only have a couple more to do. Start with this one, another second order one. Now, careful. Going back and forth with sine and cosine trips up a lot of students, and I hope you didn't mess up on your quiz today. But positive cosine's derivative is negative sine. So cosine is not the antiderivative of sine. Negative cosine is. I need negative 1/3 cosine 3x. Because of the chain rule, I need that 1/3. Same with having a 1/2 in front of the sign. If I plug in 0, I need to know that the sine of 0 is 0, the cosine of 0 is 1. So I'll just add 1/3 to 3/3 to get c as 4/3. We now need to go one extra step to find f of x. And we are going to make sure we continue to remember I need a 1/3 when I take this antiderivative of cos 3x. I'll need a 1/2 when I take the antiderivative of sine. Oops. I need the antiderivative of 4/3, 4/3 x. I need a plus c. Eight fourths plus a fourth, 9/4. After all that, we have our solution. Okay, two more. I like to end with these two to make sure we understand the differences. You see a 1/3 minus x. You see a 1/5x minus 2 squared. You could put this as a step to the first power so that you know, oh, the antiderivative involves a log. Versus the second one, since it's not to the first power, we'll use the power rule. We would rewrite this as 5x minus 2 to the negative second and use the power rule. Let's do the one on the top first. We would have the log of the stuff. That's the antiderivative of the outside. But what goes before this log? And this is where some of us might mess up. Do you need a 1/3? Do you need a -1? Do you need nothing? Are we good? Discuss. What do you need in front of that log? The coefficient of x is -1. So multiply by that reciprocal. I need a -1 there. Don't forget your plus c. Thankfully, this is just a first order. But you need to know what the log of 1 is. The log of 1 is 0. It's the same as log of e to the 0. We need to know that. So c is 1, I'll get my solution. F of x equals negative log 3 minus x plus 1. And then let's try 1 over 5x minus 2 squared. We would rewrite this, and we would use the power rule. Now, I'm going to change it, just because I want to make sure that it's one of those tougher ones where we need 2 reciprocals. So please, I'm sorry if you've already started it. Change this to a cubed for me. Change it to 1 over 5x minus 2 cubed. Okay. I would add 1 to my power, multiply by the reciprocal, and multiply by the reciprocal of the coefficient of x. I need this 1/2 from the negative 2 and a 1/5 coming from that 5x minus 2. Just going to finish this problem off, if you don't mind. F of 0 is negative 1 over 2, negative 2 squared times 1/5 plus c is equal to 2. This is 4 times 2, which is 8, times 5, which is 40. Yikes, but whatever. Negative 1 over 40 plus c equals 2, which is 80 40ths. Add a 40th, c is 81 40ths. Hey, did you all pick up the homework after you turned in your quiz? I bet not all of you did. Please make sure you do so. Thank you.